Alright, let's talk about elevation and depression and how we can use trigonometry to solve these types of issues and questions. Look, little guy, he's standing on the edge of a cliff, and the ocean below is a yacht, and up above, flying overhead, is an aircraft. If he looks directly out, he is looking out horizontally off to the horizon. If he looks down to the boat, now that creates what we call an angle of depression. So looking down is depression. If we were to look up at the aircraft, that would be an angle of elevation. Okay, so looking up, or an angle going up from the horizontal, is an angle of elevation. We don't know what this angle is, so we'll call it theta. We can also start to create some Z angles. So if you remember from your geometry, Z angles are also called alternate angles, and they're so called because of the Z pattern that they make, and we know that they are equal. So I could also work out that the angle up here, this is also theta. I can do the same for the angle of depression using that same notion of alternate angles. In this case, I've got a Z pattern, even though it's back to front, it doesn't matter, it's still a Z. So I can say, well, that angle there is alpha. The alternate angle there is also alpha. That also means now I can work out what's going on over here, because now I've got a right angle with the cliff face and the horizon and alpha. So I can work out that the remaining angle is 90, take away the alpha, and that would give me this angle in here. Right, handy to know when we're solving these kinds of problems. So let's do that. Let's have a look at a typical kind of problem. We've got a guy who's 30 meters from the base of a tree. The angle of elevation, in this case because it's elevating, looking up, is 32 degrees. And we want to know what is the height of the tree. Let's take that and we'll draw a nice simple little diagram that we can work with. This is a right angle triangle, okay, because the tree is forming a 90-degree angle with the base of the ground. So we can have a hypotenuse, an opposite, and an adjacent, and we can use sine, cos, or tan because we're working with a right angle triangle. So in this case, our angle of focus is 32. We've got an opposite and an adjacent to that angle, so we're going to use tan. We know that tan 32 equals h, in other words, the height of the tree, which is our h, which is our unknown, that's what we're trying to work out, divided by the adjacent, which is 30. Now, to get the h on its own, I multiply both sides by 30, and I end up with 30 tan 32 equals h. I can plug that into a calculator, and I get a value of 18.75 meters for the height of the tree. So there's a typical kind of angle of elevation problem.